Okay, hi Year 11, welcome to the third part of your intro video. So in this video we're looking at how do we find a missing angle in a right angle triangle when we know two sides. Well, the process starts very much the same as finding a missing side. So we want to know this angle. What we first of all do is label the sides. So here is your opposite and this is your hypotenuse. So SOHCAHTOA, which one is it? It's opposite and hypotenuse, so it's going to be a sine. So we write down the formula. Sine of your angle is equal to your opposite over your hypotenuse. Okay? So, now put into the equation what you know. Well, this time I don't know the angle. The angle is x. So sine x equals your opposite, which is 7, over your hypotenuse, which is 10. Okay? Now, here's the tricky bit that you have to remember. How do we make x a subject of this formula? What we need to do is we need to inverse the sine. Okay? And so the inverse of sine is what we write it like this. Okay? Sine to the minus 1 of 7 over 10. Okay? And again, we're just going to use a calculator. So if you look at your calculator and look at the sine button, right above it in yellow, or it'd be in yellow, it says sine to the minus 1. So how do you get that? What you do is you push shift sine, and then put 7 over 10. Okay, put your fraction in. And as long as you've got your calculator in the right setting, D rather than R, okay, then it will tell you that the angle is 44.4 degrees to 1 decimal place. Now, angles we always put to 1 decimal place unless the question says different. Sides, 3 significant figures, angles, 1 decimal place. Okay? So that's how that is done. It's just making sure you use the calculator correctly. It's shift sine. That is the opposite of doing a sine. Okay, so that's how we solve that equation. It's just showing you that I'm right. Okay. 44.4 degrees. So maybe stop the video and see if you can find out what x is in this example here. Okay, what angle is that? Okay, so again, first things first, let's label the sides. Well, 5 meters is the adjacent side, and 8 meters is the hypotenuse, the one opposite the right angle. So, which one are we going to use, sine, cos, or tan? It's adjacent and hypotenuse, so it's definitely a cosine. So, cosine of your angle is equal to adjacent over hypotenuse. So, put in what we know. Well, we don't know the angle, that's x. The adjacent is equal to 5 and the hypotenuse is equal to 8. So now how do I find x? We do the inverse of cosine, cosine minus 1 of 5 over 8. Okay, so look for that button in your calculator. It will be shift cos, and then put the fraction in. Okay, 5 over 8. So I'm just doing that now. And I get an answer of 51.3 degrees to 1 decimal place. 1 decimal place for angles. Okay? Hopefully that makes sense. Should be nice and easy. So let's just see whether we were right. It was a cos. And 51.3 degrees. So we got it right. Okay, so here's the process for finding an angle. Okay, label the sides, exactly the same as finding a side. Okay, work out which bit of SOHCAHTOA to use. It's the same process. Okay, substitute in the numbers and solve the equation. The process is exactly the same. The only thing that is different is when you're using your calculator, instead of putting cos, you need cos to the minus 1, which is shift cos. And then put shift cos and what the number that you need to go into a calculator, it will give you your answer. Okay? So any problems with that, let me know. Right, now, what we're going to do, a little bit of work on using basic trigonometry to solve some very basic problems with things called angles of elevation and angles of depression. Now, an angle of elevation is an angle as you might look up into the sky, okay? So it's always, what's the angle from the horizontal line, from the horizontal to looking up? So this woman here is looking up at a hot air balloon. The angle of elevation is the angle from the ground up to where the balloon is, okay? Now, an angle of depression is also measuring from horizontal, okay? So imagine there's someone in this balloon and they're looking down at the woman. Well, the angle of depression is from the horizontal line, okay? From the horizontal line, what angle does she look down in order to look at the woman on the ground? Okay? Some people think this is the angle of depression. It's not. We have to measure from the horizontal. Okay? I hope that makes sense. So, here's a basic question. From the top of a vertical cliff 120 meters high, Georgia can see a boat out to sea. The angle of depression from Georgia to the boat is 49 degrees. How far is the boat from the base of the cliff? So, and we need to do it to one decimal place. So what you do when you get a situation like this, you always draw a picture. Okay, here is a cliff, and it's 120 meters high. Okay, Georgia is standing on top of the cliff, and she can see a boat, okay, on the sea. So here's the sea, and here is my boat. Okay. So make a triangle. It says the angle of depression from Georgia to the boat is 49 degrees. Now what I see many students, sorry guys. What I see many students doing here is they say, well, this angle is 49 degrees then. No, it is not. That angle is not 49 degrees. The angle of depression is 49 degrees. So what we have to do is take the horizontal. Okay, it's always from the horizontal. It means this angle is 49 degrees, which means we can very easily work out what this angle actually is. It should be 41 degrees. Okay? Now what we want to know is how far is the boat from the base of the cliff? So I want to know what this distance here is. Okay, the distance from here to here. So we'll call that distance x. And if you've made your diagram correctly, it's now a simple trigonometry question. Label the sides of your right angled triangle. This is the opposite. This is the adjacent. So it's a tan. Tan of your angle is equal to the opposite over the adjacent. Substitute in tan 41 equals x over 120. So x equals 120 times tan 41. Okay, put that in your calculator. 120 times tan 41. Okay, and the answer is 104 meters to 3 significant figures. Okay, so be very careful with what the angle of depression is. That's not the angle of depression. That's the angle of depression from the horizontal. Okay, let's just have a look what they did. Something similar. Okay, and there we go, we got the right answer. Oh, so actually what I didn't do is I didn't read the question correctly because it said 1 decimal place and I did it to 3 significant figures. So naughty me, make sure you read the question carefully. The answer was 104.3 meters to 1 decimal place. Okay? So, by now you should be able to understand the trigonometric ratios, sine, cos and tan. You should be able to find unknown sides, you should be able to find unknown angles, you should be able to use your calculator, and you should be able to understand angles of elevation and depression. Okay, so if any of that you do not understand, then please get on the call and let me know, and I will help you.